whenever integration of secant x tan x is given, I can write the function as secant x plus c. Simultaneously, whenever d by dx is given with the integral, then the value of the function is the derivative itself. Secant x tan x is the derivative of secant function. Therefore, integration of secant x tan x dx can be written as secant x function plus c. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are going to take up a very important chapter, that is integrals. So integrals is nothing but an inverse process of differentiation, and here in this session we are going to learn integrals in the form of an anti-differentiation. So you can expect around 22 marks from this chapter. As I said, a very important chapter for your examination also. So you will be getting questions in all the sections from part A to part E, including 1 mark, 2 mark, 3 mark, 5, 4, 6 marks questions here. So let's move on to integrals. Now what is integrals? The integral calculus arises out the efforts of solving problems of the following types. So why integration has arisen? Because the very first thing is problem of finding a function whenever its derivative is given. So sometimes we are given with the derivative, we are supposed to find out its original function. For example, if I say find the derivative of sin x, you will clearly say it is cos x. And similarly, whenever a function is given as cos x, what is its original function? So that is sin x. So that is why integration has occurred, and hence it is called as anti-derivation also. And one more thing, why integral calculus are used or why it existed, because it helps us to find a area under the curve. That is, whenever the area is bounded by the curve, we are supposed to calculate that area under the given conditions with the help of integration. Now, there are two forms of integral. One is indefinite integrals and another one is definite integrals. Indefinite integrals always ends with the constancy, which we will study it later, and definite integrals will be exactly the function given under the different conditions where we can find the original functions of a given derivative. And both of this, that is indefinite and definite, constitute to form an integral calculus. Now we will see integration as a process of anti-differentiation. So integration of a given function whose derivative could be recognized with the help of the given derivative. For example, integration of cos x is sin x with respect to x. How? Because derivative of sin x is cos x, and hence we can write integration of cos x with respect to dx is sin x. So this is the symbol used to write the integration, and similarly here you can see this is how we are going to write. If derivative of sin x is cos x, then integration of cos x with respect to dx will be sin x, because so here cos x is nothing but the derivative of sin x, and hence integration are used to find the function whose derivatives are given. Similarly, you can see here integration of secant square is tan x. Why? Because derivative of tan x is secant square x. So thus secant square x is derivative of tan x, and hence we can write integration of secant square x with respect to x is tan x. Similarly, integration of x dx is x square by 2. How? Derivative of x square will be 2x. But if you derive x square divided by 2, so if you divide both sides by 2 here, then here 2 get cancelled. Thus, derivative of x square by 2 is x, and thus integration of x with respect to dx become the original function, which is x square by 2. Similarly, integration of e power x is e power x only, because derivative of e power x is e power x. I already said you indefinite integral always ends with the constant c. Why? Because when you derive it, the result is obviously 0, and hence we can write c as an integration constant, which helps us to find the family of the functions here. But when you derive it, it becomes 0. So thus we can write all integration ending with constant c. This is only for indefinite integrals. So in general, we write integration of f of x dx is equal to f of x plus c, where c is called as constant of integration, and these type of integrals are called as indefinite integrals, or simply integral of f of x with respect to x. So next we have a method of inspection, that is finding the integral of a function by inspecting. So how we can inspect? Since we know the standard derivative, that is for derivation of sin x it is cos x, for cos x it is minus sin x, for x square it is 2x, for x cube it is 3x square. Since we know the standard derivatives of certain function, so if the derivatives are given, we can recognize the function, which will become the integral value for the function. So here are some examples I have taken. Since derivative of secant x is secant x tan x, whenever integration of secant x tan x is given, I can write the function as secant x plus c. Similarly, derivative of x is 1. Thus, integration of any constant with respect to dx can be represented in terms of x plus c. So since we have here 1, we can clearly write x plus c. Suppose we have an integration of 2 into dx, I can write this as 2x plus c. So integration of any constant with respect to dx can be written as constant into x plus c. So like this, here I have listed some of the standard integrals. Since we know the derivative of the function, we can recognize its function, which will become the integral value. That is why here are some standard integrals here. So derivative is listed here, and vice versa, the antiderivative is also listed. If derivative of x is 1, then integral of 1 is x. Derivative of x square is 2x. Thus, integral of x, so only x becomes x square divided by 2 here. And here, integral of x square becomes x cube by 3. So, in general, integral of x to the power n with respect to dx can be written as x into n plus 1 divided by n plus 1. You can observe here, x power is 1, 1 plus 1, 2 divided by 2. X square is 2, x cube means x to the power 2 plus 1 divided by 2. So, for any power of a polynomial function here, it can be generally expressed in the form of x to the power n plus 1 divided by n plus 1 plus c, where c is the constant of integration. Similarly, for root x. So, for root x, if you have x to the power half into dx, then it is x to the power half plus 1 by half plus 1. So, which becomes x to the power 3 by 2 by 3 by 2. We can write it as 2 by 3 x to the power 3 by 2 plus c. So, here is how we have recognized. So, we can also write like this. And derivative of root x is 1 by 2 root x. If you want 1 by root x, then its derivative is 2 into root x. And next is derivative of 1 by x becomes minus 1 by x square, because x to the power minus 1 means it is n into x to the power n minus 1. So, which becomes x to the power minus 2, and hence we will put it in the denominator. That is why integration of 1 by x square is minus 1 by x. So, sign interchanges when you have minus in terms of derivative, and in the case of integral it goes to the antiderivative. And here derivative of sin x is cos x, we know. That is why integration of cos x is sin x. Derivative of cos x is minus sin x, and hence integration of sin x is minus cos x. So, sign interchanges. And here tan x is secant square x. That is why integration of secant square is tan x plus c. Similarly, you can see for cot x, its derivative is cosecant square x. Therefore, integration of cosecant square x is minus cot x. And here secant x is secant x tan x. Integration of secant x tan x is secant x plus c. And here derivative of cosecant is minus cosecant and cot. That is why integration of cosecant and cot is minus cosecant x plus c. And these are the standard derivatives of inverse trigonometric function, and hence here sin inverse x derivative is 1 over root of 1 minus x square. Thus, integration of 1 over root of 1 minus x square can be directly written as sin inverse x, and similarly you can see for tan inverse and for secant inverse. So, whenever integration of this function is asked, you can directly write as tan inverse x. When integration of this function is asked, you can directly write it as secant inverse x. And similarly, for e power x, it is e power x. Therefore, integration of e power x is also e power x. Log x is 1 by x. Therefore, 1 by x is log x. A power x is a power x log a. Here, a power x become a power x divided by log a. So, you can clearly say it is a power x divided by log a. So, thus, clearly we can say if derivative of a function is known, we can recognize the integral or the function of which derivative is given, and hence integration is nothing but the inverse process of differentiation, and hence it is also called as antiderivatives. Thus, by knowing the standard derivatives, we can recognize the standard integrals, and this method of inspecting the function when its derivative is given, it is called as method of inspection of finding integral. Now, let's move on to some of the properties of integrals. The first property of the integral says, whenever the derivative and integral of the function is given, the value is just f of x. That is, whenever d by dx integration of e power x dx is given, then the value must be e power x only. Let's check this now. So, first let us integrate e power x. What is the value of e power x? Integration of e power x dx is e power x only. So, that is d by dx of e power x plus c. Now, let us derive it. What is derivative of e power x? It is e power x. What is derivative of constant? It is 0. Hence, the value is e power x. So, simultaneously, whenever d by dx is given with the integral, then the value of the function is the derivative itself. Similarly, integration of d by dx also gives you the same function. And next, property number 2 says that whenever two integrals have the same value, they are equivalent. That is, two indefinite integrals with the same derivative leads to the same family of curve, and so they are equivalent. Suppose f of x dx gives you the same value of integral, g of x d of x gives you the same value of integral. That means they are denoting the same family of curves. Next, property number 3 says, whenever any function is given in the form of f of x plus or minus g of x, whose integral has to be found, then first integrate the first function separately, then integrate the second function separately. For example, whenever integration of sin x plus x is given, so then apply sin x dx separately and for x dx separately. So thus, what is integration of sin x? Integration of sin x is minus cos x. And what is integration of x? It is x square by 2 plus c is the integration constant. So, whatever the standard integrals I have listed previously, you have to learn all those standard integral. Since you know the derivative, you can easily recognize the integral. Thus, by learning the standard integrals, we can simplify some of the problems easily. Next is property number 4 says, whenever any constant is multiplied with the function, take out the constant outside and derive only the function. So, for example, whenever any integral of 2 secant square x dx, we have to find the integral of this function. Since 2 is a constant and it is multiplied, take 2 outside, integrate only the given function. So, we know that derivative of tan x is secant square x. Therefore, integration of secant square can be written as tan x plus c. So, this is how we integrate. So, any constant multiplied with the function, take out the constant outside and then integrate only the function. Similarly, it can extend to n number of values also. Thus, here it is called as linear property. This is what the property 5 says. When functions are given multiplied with any constant, take out all the functions from the integral and integrate each and every function separately to get the integral value. So now we will integrate the given problems with the respect to x here. But before integrating this, you should know all the standard integrals as well as the standard derivatives of a function. So these are all the derivatives where we are using only the method of inspection. Just learn the standard integrals and you can easily write the integral value of the given function. So these kind of questions carries 1 marks. So very simple when you know its standard integral form. Now here they have given integrate the following with respect to x. Integral of 2x minus 3 cos x plus e power x. Through the linear property, whenever you have constant inside the function, take out constant and integrate the function separately. So therefore here I can write this as 2 into integration of x dx minus 3 into integration of cos x dx plus integration of e power x dx. So now 2 into integration of x. So any x to the power n dx, it is nothing but x to the power n plus 1 by n plus 1 plus c. And integration of cos x dx, here cos x is derivative. So derivative of which function? It is the derivative of sine function, and hence here I can write sine x plus c. Next we have e power x dx. So here is the derivative e power x. So e power x is the derivative of e power x only. So therefore it is e power x plus c. So thus here the answer is 2 into x square by 2 minus 3 integration of cos x is sin x plus e power x plus c. So we can cancel 2 here. Therefore x square minus 3 sin x plus e power x plus c. Next question. Integration of sin x plus cos x dx. Sin x separately, integrate cos x separately. So sin x is a derivative. Sin x is the derivative of which function? It is the derivative of cos x function. Derivative of cos x is minus sin x, and hence integration of sin x dx can be written as minus cos x. And similarly, integration of cos x dx, we have already written, it is sin x plus c. Next, secant into secant x plus tan x. Let us write this. Integration of secant square x plus secant x tan x dx. Secant square x is the derivative of tan function. Therefore, integration of secant square x dx can be written as tan x. Next, secant x tan x is the derivative of secant function. Therefore, integration of secant x tan x dx can be written as secant x function plus c. Next, 2 into e power x. Take 2 outside, e power x dx, and integration of e power x is e power x only. So 2 e power x plus c. Next, root x plus 1 by root x dx. So root x we have, thus here I can take this in the form of x to the power 1 by 2 plus 1 by root x into dx. So let us apply the integral property here. So here we get x to the power 1 by 2 means x to the power 3 by 2 divided by 3 by 2. That is x to the power n plus 1 by n plus 1. And here also 1 by root x can be written as 2 root x because derivative of root x is 1 by 2 root x. So thus if you apply integral here, then 2 root x is its integral value. Thus, I can easily write here 2 root x plus c. And here I can write it as 2 by 3 x to the power 3 by 2 plus 2 root x plus c is the integral. Next, x cube minus 1 by x square. So, first derive both the numerator by x square. X cube by x square is x minus 1 divided by x square dx. So, here I can write x minus x to the power minus 2 into dx. So, now here integral of x separately it becomes x square by 2 because it is 1 plus 1 minus x to the power minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1. Remember, integration of x power n with respect to dx is x to the power n plus 1 divided by n plus 1 plus c. So, here I have taken the power into the numerator so that it becomes negative. Hence, minus 2 plus 1 is minus 1 minus 1. So, we have here plus c, thus x square by 2 minus into minus is plus. X to the power minus 1 can be written in the denominator. So, it is 1 by x plus c. Next, 3 power x dx. We know that derivative of a power x is a power x log a. So, this is the derivative. So, now apply integral this side for a power x. So, if you apply a power x dx, then this side it becomes a power x divided by log a. So, thus integration of a power x dx is a power x by log a. And hence here in the place of a we have 3. So, therefore, the answer is 3 power x divided by log 3. Next one, 1 minus x into root x dx. Let us multiply root x minus x root x becomes x to the power 3 by 2 into dx. So, root x is nothing but 1 by 2. So, x to the power 1 by 2 plus 1 by 1 by 2 plus 1 which becomes x to the power 3 by 2 by 3 by 2. Minus here x to the power 3 by 2 is given, x to the power 3 by 2 plus 1 by 3 by 2. Therefore, 5 by 2 divided by 5 by 2 plus c. So, thus we can write it as 2 by 3 x to the power 3 by 2 minus 2 by 5 x to the power 5 by 2 plus c. Next question, square root of 1 minus cos 2x. A simple trigonometric function is given. I can take cos 2x. So, now we know that cos 2x can also be written as 1 minus 2 sin square x. So, if you replace these two, 1 minus cos 2x can be written as 2 sin square x here. And thus here I can write it as integral of 1 minus cos 2x I can replace with 2 sin square x dx. So, here I can take root 2 outside because it is a constant. So, root of sin inverse x is sin x dx. What is integral of sin? It is minus cos x plus c. Next, e power x minus x power e plus e power e. So, integration of e power x is e power x only. X to the power n means x to the power n plus 1 by n plus 1. So, e is a constant, hence we can write x to the power e plus 1 by e plus 1. E is constant, power e is also constant, thus e power e is a constant. Hence, integration of e power e become e power e into x. When you integrate any constant with respect to dx, I can write it as k into x. Thus, e power e is a constant, and when you integrate e power e with respect to dx, we will get e power e into x only. That is why I have written here e power e x plus c is the integration constant. These type of integrals are found by the method of inspection. So, learning the standard integrals helps us to solve these kind of problem, and today in this session what we have solved is purely for 1 mark questions. So we will see few more method of integrations in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.